Hey, here we're going to factor out a common term, and the expression we have is 12x squared y cubed plus 4x y squared minus 20x to the fourth y squared. So the best thing to do here, since there's multiple terms, is to go through and kind of look at each similar part. So let's look at the coefficients, 12, 4, and 20. So if I want to pull something out of there, it looks like 12, 4, and 20 all have a common divisor of 4. So I'm just going to kind of start building the leftovers here. So if I pull 4 out of 12, it'll be 3. If I pull 4 out of 4, it'll be 1. I'll put that as a placeholder just in case. And 4 out of negative 20 will give me negative 5. So then I will move on to the next term, which are the x's, and I have an x squared, an x, and an x to the fourth. So I can only pull out the smallest exponent possible. So that would be an x to the first. I'll just write x there. So if I go to the first one, if I pull an x out of x squared, there'll be x left. If I pull an x out of x, they'll all be gone. And if I pull an x out of x to the fourth, it'll be x cubed. Okay. And the last thing we have is the y's. So here's a y cubed, a y squared, and a y squared. So I can pull out a y squared because there's a y squared in all three of them. If I pull a y squared out of y cubed, there's a y left. Y squared out of y squared, they're all gone. And y squared out of y squared, they're all gone. So one thing that was kind of useful here to see was that this middle term, 4xy squared, I was able to pull all of that out. And when I did, I needed a placeholder because I need to think that if I push this back in using the distributive property, that I will collect that middle term. And if I don't have that 1 there, I'll lose it. But my final answer is on the outside, 4xy squared, and then times the quantity of 3xy plus 1 minus 5x cubed. Thank you.